Okay, trig functions 6.1. Alright, for these first problems, I want you to try them on your own, and we'll probably talk about them, well, not probably, we will talk about them in class, next class, because I wanted to make sure everybody gets this information. So, try them on your own, see what you can figure out. Don't worry too much about them, though. We can talk about them in class. I want to make sure we all have this down. Alright, so this stuff, other stuff, the set. Okay, dealing with that Ferris wheel. So we're dealing with these things again. Kind of like we did on our Ready, Set, Go. Or like we did in class, sorry. So, they've got that big Ferris wheel. So the passenger capsule at the very top is 135 meters above the ground. And the diameter is 120 meters. So, that length across here is 120. So our radius, right, half of that would be 60. And we're told that from the ground to the very, very top is 135 meters. Okay? So how high is the center of the Ferris wheel? Okay. Well, think about that. The top is 135, right? And 120 of that is the actual Ferris wheel. Okay, so what's the difference, essentially? A few different ways you could do it. You could take 135 and subtract 60, and those are meters, those shouldn't be degrees, and subtract 60, and that should tell us. Or you could take 135, subtract 120, that would give us the height right here of the ground, and then, 60 plus 15, but either way you should have ended up with 75 meters. Okay, how far from the ground is the very bottom passenger? Oh, we kind of already did that. That's 15, right? Should be able to get that. Now, A, assume there are 36 passenger capsules evenly spaced around the circumference. Find the height from the ground of each of the numbered passenger capsules. Use a figure on the right to help you think about the problem. So what we're doing here is making those triangles again. Okay, only this time you're making more. Now, I want you to do this on your own, but just remember that, this distance from the middle up is 75, and each of these degrees, well, there's 36 of them, so a full circle, 360 divided by 36, is going to give us, what that degree is, which is 10. So those are 10 degrees. You can make a bunch of triangles here. You know the hypotenuse of each one. And if you think about it, if you know this one quarter, you can figure out the other quarter and the other quarter. Okay? So I want you guys spending time on this one. This is good practice for you guys to get it. So you're going to use those trig ratios. Now that you know the degree, right, you're going to end up making a, and let me go down here. You're going to end up making a bunch of triangles, right, where that's 10 degrees, and then the next one up would be twice that, so 20 degrees. The hypotenuse is always going to be 60 meters, and you can figure out what those lengths are, and then add that to the 75 to find that. Okay? So it's good practice, so you're always going to be looking for the opposite over the hypotenuse, so you're always going to be dealing with the sine. Right? So that would be the first one. So you'll end up going 60 times the sine of 10. And then the next one would be 60 times the sine of 20, and so on. And then think about how that would relate for the rest, for this piece, and that piece. Alright. Now this one, the go, this is dealing with that trig again. So you're finding the other two trig ratios based on the one that is given. So you've got a triangle, a right triangle. Sine, we know, is opposite over hypotenuse. So my hypotenuse is 5. My opposite side is 4. We'll say this is the angle we're going with. Okay, do we know what the cosine is? Do we know what the tangent is? Okay, well, we can figure that out fairly easily. Okay? We just use the Pythagorean Theorem. 5 squared equals 4 squared plus, we'll call that the adjacent side, a squared, Well, that's 25 equals 16 plus a squared. Subtract 16. And we get 9 equals a squared. Take the square root of that. We get 3 equals a. Okay? So that would tell you the three sides of your triangle, which then, cosine would be the adjacent, 3 over 5. Tangent, opposite over adjacent, 4 over 3. So do the rest. With these, you're given one piece. Okay? Use that to try to figure out the rest. So, make a triangle. Put what you know, figure out what you don't, using the Pythagorean Theorem. Alright, now remember, converting degrees from radians and back and forth. If you're given degrees, put it over 1, times it by pi over 180. Okay? So we'd have 345 times pi over 180. Don't just stick that in the calculator. What you're looking at doing is reducing. Okay? So let's think about this one. So I could divide 5 into it, right? 345, 5 goes into 36 times, and 45, 5 goes into 45, 9. So you'd have 69 pi over 180 divided by 5. I'm just reducing the fraction. 180 divided by 5 would be, I don't have a calculator with me, so I'm doing this either in my head or by hand. So that would be 3, 15, 6, 36. Okay? Well, we can take 3 out of it, right? Divided by 3 would be 23 pi over 12. Can we reduce it further? I don't think so. So there we go. Okay? So it's as easy as that. You're just mainly, when you've got the degree and finding the radian, you do it that way. So negative 135, treat it the same way. Okay? You just end up putting it over 1, times it by pi over 180. So it would be negative 135 pi over 180. And then see how you can reduce that fraction. Okay? So that one you'd probably end up with, if we did it by 5, it would be 17 pi over 36, we said. Which I don't think we can reduce that further. Okay, now 17, this time, when you've got the pi, you times it by 180 over pi. So what happens first is the pi's cancel out, and then you can either reduce or deal with it how you want to. I like to reduce first because I know 180 is 2 times 90. So that'll get rid of my 2's, and then I'm left with 3 times 90, which is 270 degrees. You could go 3 times 180 and get 540, divide that by 2, and end up with the same thing. Okay, so 18, you do it the same way, 180 over pi. So the pi's cancel. 180 is like 6 times 30. Those cancel. 13 times 30. 0.9003. 390. Negative. Okay? Now, for those reference angles, remember you're looking at the smaller part of the angle. So when they give you the graph, that's fairly easy to deal with. Okay? So they tell us that whole angle is 110. Alright? So I know that this right here is 90. So that would be 20 degrees. So we're wanting to know what this angle is right here. So 90 minus 20 would give us 70 degrees. Be our reference angle. Okay. On 20, they go to negative 720. And the way you're really looking at it is we need to figure out where we get to for that 90, right? So around once is 360. And around 3/4 is 270. So 360 and 270 gives us 630. So 710 minus 630 gives us how many left over? So make that 11 with a 6. So that would be 80. So if this is 80 degrees, that angle right there would be 10 degrees. Now, when you're dealing with just regular numbers, the easiest thing to do, honestly, is graph it. So we know that's 180 is half a circle, so I'm going to go an extra 100, okay, to get to 280. So how much more did I go over? Well, we went over an extra 10 degrees, right? So that would be like a negative 80 degrees. Okay, 490. I know that I'm going complete circle because that's 360. 490 minus 360 would give us 130. So I'm going past 90. So if I minus 90 from that, that would give us 40. So we'd go an extra 40 out there to that one. So that angle would be 50. Okay, now to find a positive and negative coterminal angle, just take your angle and add 360, because coterminal is where they're going to end, right? So 245 would be somewhere right here for my angle. So I would just go, that's 245. So if I go another 180 that way, gives me this, or another 360 that way, it gives me my angle. So 605 would be a positive. And then if I subtract 360 from it, we would get 360 minus 245. Now that wouldn't get it for us. We want that. So we're going to have to, it's a little trickier to do, isn't it? We can't just subtract it when it's a smaller number like that. Because that would not work, because it would go into the negative, right? So we just go 360 minus 245 and then put it negative, right? So that would give us 5, 1, 1. So it would be negative 150. Okay? So, for like 300, adding 360 to it would give us an angle of 660. Subtracting 360 from it would be negative 60. Okay, 24, subtracting 360 from it, this one kind of works backwards, would give us negative 480 for one of those reference angles. Adding 360 would be 360 minus 120, which would be 240. Alright? So, there you guys go. How to do those ones. We'll talk more about all of this, and especially about this first page and this second page. First page for sure, the second page, we'll probably talk a little bit about it to just make sure you guys know what's going on as we jump into the next stuff. So, there we go.